We'll talk about the properties of graphs, how you can find out what they are, and how to modify them. First, some terminology. MATLAB uses what it calls handle graphics in all of its figures. All figures consist of different objects, and each object is assigned what is called a handle. The object handle is a real number that's unique to each object, and that's how you refer to the object. Don't try to make sense of what the actual real number is, however. All of the plot functions return a handle for the plot object, which can then be stored in a variable. That handle will remain valid as long as the object exists, which means as long as the figure window is still open. So if you close the figure window, all of those handles become invalid. The objects within plots or within the figure window include graphics primitives or core objects such as lines and text, and also the axes that are used to orient the objects. The objects are organized hierarchically, and there are properties associated with each object. In object-oriented programming, we talk about parents and children. A parent comes before its children in the hierarchy, and generally children inherit properties from the parents. In the handle graphics in MATLAB, the figure window and axes are parents. The axes are what are used to orient its children, so all of the different plot objects and the core objects. We can use the get function to find out what the object properties are. Get and then an object handle will display the property names and the values for that particular object that you're referencing by the handle. For example, assume that you have x and y vectors and you use them to create a plot using the plot function. And instead of just getting the figure window, we store the result in a variable plot h. So plot h now stores the handle of the plot object. As long as the figure window is still open, we can use the get function to find out what the properties are of that object. So get plot h, for example, will show the properties of the plot function. You can see some of them are not going to make much sense, display name, annotation, but we can see, for example, the color is a vector given by three numbers 0, 0, 1. So the way that works is the first number is the red, the second is the green, and the third is the blue. So what this says is 0 red, 0 green, full blue, which means the color is actually blue. And you've probably noticed that that's the default color on graphs. You see the line style is a dash, and the line width is 0.5. And there is no marker that we specified, like an asterisk or something like that, for the individual points. So those are just some of the properties. So you notice with the get function, what you see is the actual name of the property followed by the property. If you assign the result of the get function to a variable, what happens is it becomes a structure variable, a structure in which the property names become the field names. So for example, if we say get plot h and store the result in a variable, plot struct is now a structure variable that has the property names as the field names. So we can use the dot operator to refer to the different fields within the structure. For example, plot struct dot line width shows us that the line width was 0.5, as we saw on the previous slide. You can also get a particular property by specifying the name of it. For example, if we say get plot h, comma line width, we see that the line width is 0.5. There are some built-in functions that return the handles for the current axes and for the current figure. GCA stands for get current axes. GCF stands for get current function. So for example, if we have the plot function handle plot h still, and we say get plot h parent, what we want is the value of the parent object. And again, you see that it's a real number. You won't be able to make sense of the real number. But you can see that we get the same real number with GCA. So in other words, the parent of the plot function is the axes that are used to orient it. The GCF function gets the current figure. So if you have different figure windows open, figure 1, figure 2, figure 3, etc., it'll tell you the number of the current figure. For example, if we're on the first figure, GCF would return 1. So we can use the get function to get the properties. We can use set to set the properties or to change the properties. The way set works is you pass the object handle and then pairs of values, where in each pair the first is the name of the property and the second is the value that you want it to have. So for example, we can set properties when we call a function to begin with. For example, if we say plot x comma y comma, we can set the line width to be 3.5 instead of the default of 0.5. Or if you've stored the result from the plot in a handle variable, for example plot h, then after getting the plot you can use the set function to set the property. So you can set the property when you call the plot function to begin with, or later using the set function if you have a handle for it. Here's question number 1. So here's code that will create a stem plot. So creating x and y vectors first, and then creating a stem plot and storing the handle in a variable. So the first question is to use set to change the color to red from the default, which would be blue.